Okay, hello. I'll be going over this problem. It says calculate the vapor pressure, sorry, I meant to say of a solution made by dissolving 110 grams of glucose in 930 milliliters at 25 degrees Celsius. The vapor pressure of water at 25 degrees Celsius is 23.776 mm mercury. The density of the solution is 1 gram per milliliter. Okay, so the first thing that we want to think of when solving this problem, it asks for the vapor pressure of a new solution. So we want to use Raoult's law. So Raoult's law states that the pressure of the solution is equal to the mole fraction of the solvent times the pressure of the solvent. Okay, so we know it right here in the problem. It says the vapor pressure of water, so of the solvent, is 23.776. So we have this. So that's good. Okay, so now we need the mole fraction to solve this. So the mole fraction is going to be, and as for the solvent, so the mole fraction of the solvent is the moles of the solvent divided by the moles of the solution. Okay, so right here it gives us that there's 110 grams of glucose. So we want to turn that into moles so we can add it into the moles of solution. So let's do that first. So it's 110 grams of glucose, and then we need to turn that into moles. So in glucose, if you calculate it out, there's about 180.2 grams. Grams per mole. So if we calculate that out, that's going to be 0.61043. Okay, moles of glucose. Okay, so that's good. So now we just need the moles of the solvent. So in here it gives us that in one that the density, so the density is mass divided by volume. So the density is 1, and then it gives us the volume of the water in milliliters. So let me write it right here, which is 110. Which is 930 milliliters. So 930 milliliters. Okay, and then we want to see what's going to be the mass of that. So if we multiply this out, we can see that this is going to be about 900. This could be about 930 grams. Okay, so now we need to turn this into moles. So in water, there is 18 grams per mole. So 18 grams, 1 mole. And then let's see how much that is. So 930 divided by 18. It's going to be 51.667. Okay, so now we have all the components we need. let me write the moles of H2O. Okay, so I'll scroll down just a little bit. So we have the moles of the solvent, which is 51.667 divided by the moles of the solution. So the moles of the solution, all we have to do is take this number right here and add it to this number. So it's going to be 0.61043 plus 51.667. And now, look, so now we have the mole fraction. And remember, they gave us the pressure of the solvent in the beginning, so we can multiply that out. Okay, so once we multiply that out, see what we get. So for the mole fraction, I got 0.9883, and if I multiply this by the 23.776, that's gonna be 23.498 mmHg mercury. And let's check if this is right, because okay, so the initial pressure of the solvent was 23.776, and our solution is actually lower, and that's what we want. If we get a higher value, we know we did something wrong, and that's what Roults laws tell us. The pressure of the solution is actually going to go down compared to the solvent. So it's the answer. So thank you for watching.